On today's episode, a new satellite to measure the other greenhouse gas, methane. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. On Monday, March 4th, the 20th SpaceX Falcon 9 launch of 2024, called Transporter-10, delivered multiple satellites into Earth orbit on a rideshare mission. And amongst the small satellites deployed was an emissions monitoring satellite called MethaneSAT. Built in Colorado by the Space and Mission Systems Unit of BAE Systems and Blue Canyon Technologies, the satellite was not developed by a national space agency or a private company, but unusually by a global nonprofit, the Environmental Defense Fund. The program goal is to monitor methane and pollution primarily from oil and gas operations. Methane is a powerful greenhouse gas, one which has been largely overlooked in the global drive to reduce emissions. Cracking the methane problem is now a priority, as the Biden administration has proposed rules for a fee on excess methane emissions, and European legislation will soon require methane emissions data from gas importers. Two of the largest importers of liquefied natural gas, Japan and Korea, have similar plans to require reporting. At the recent COP28 conference, over 50 companies declared an oil and gas decarbonization charter, calling for an effective elimination of methane emissions. As the primary component of natural gas, methane is widely regarded as a cleaner transition fuel for the move away from liquid hydrocarbons and is routinely piped through 1,900 pipelines worldwide. Gas is lost through leakage, as well as accidental and deliberate rupture of pipelines and gas infrastructure. And a significant amount of methane is intentionally flared as a byproduct of oil production and refining. While flaring eliminates the methane, it generates CO2. Methane could be captured, purified, and compressed or liquefied, but it is commonly flared where there is insufficient economic value in recovered gas to justify the expense of the technology. MethaneSAT will monitor oil and pipeline companies to ensure limits compliance, and the resolution of MethaneSAT will allow the mapping of emissions from oil and gas operations around the world, pinpointing small, diffuse sources in quantities as little as 400 kilograms per square kilometer. Large point emitters generating over 500 kilograms per hour can be located with precision, and the satellite is capable of detecting excess methane at concentrations as low as 3 parts per billion, the highest resolution yet achieved in an orbital system. The orbital period of the satellite is 95 minutes, scanning a path 200 kilometers wide. The sensing technology itself is a pair of passive infrared littrospectrometers detecting oxygen and methane using mercury-cadmium tellurium photodiode detectors for high resolution of weak signals. Partners on the project include Harvard School of Engineering and Applied Sciences, the Smithsonian Astrophysical Observatory, and the New Zealand Space Agency. Reduction targets are ambitious. 150 countries have signed a Global Methane Pledge to cut methane emissions by at least 30% from a 2022 baseline by 2030. And as a transition fuel, especially from coal, natural gas is expected to remain widely used worldwide for decades to come. Now, tracking it down where it escapes will be a little easier. Well, that's it for today's episode of This Week in Engineering, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.